Let's solve few problems on homogeneous differential equation. See, now the problem basically is, so all these problems, first you have to show that it is homogeneous and then solve it. The first one, so dy by dx, x plus y divided by x. Guys, it's very simple to solve it. So what do? You take x is equal to lambda into x, correct? Y is equal to lambda into y. Now what do? Substitute. So y dash lambda into x plus y divided by lambda into x. This is of the form lambda power 0 into f of x comma y. Isn't it? So it is a homogeneous differential equation. Now the solving part comes. So what do? First you need to substitute y is equal to v into x, correct? When you substitute y is equal to v into x, dy by dx is equal to, first is v plus x into dv divided by dx, right? So let's substitute. Okay, so when you substitute, the LHS is going to become v plus x into dv divided by dx is equal to, in the numerator you have this. What you can do is just divide it separately. That means you can write this as x by x, that's 1 plus y by x. But what is y by x? V. So we got v plus x into dv by dx is equal to 1 plus v. The v and v cancels out. X into dv by dx is equal to 1. So dv is equal to 1 by x dx. Correct. Now at the final part we need to integrate this. So integration of dv is v is equal to log of x plus log of c. Okay. So v is equal to log of x into c. Take the e power. That means you are going to have e to the power of v is equal to x into c. But what is v? Oh, sorry, this is v, not y. This is v. What is v? V is y by x. So we get e to the power of y by x is equal to x into c. So this is going to be the final answer for the first one. So what did we do? First, we proved that it's a homogeneous differential equation. From that, we calculated the answer for that particular differential equation. Make sense? So this is how you are going to solve the first one. Now let's go and solve the second one. See the second problem now. See what we have is, take the dx on the other side. So you're going to have x minus y dy is equal to x plus y into dx. So dy by dx, x plus y divided by x minus y. Now what do we do in the solving part? So we are going to take y is equal to vx, right? Substitute. So you have dy by dx is what? V plus x into dv by dx is equal to, now you have x into this one, x plus vx divided by x minus vx. Now numerator denominator you can take x common, right, on the RHS. See, you are going to have v plus this is equal to 1 plus v by 1 minus v. Take the v to the other side. So you have x into dv by dx is equal to 1 plus v by 1 minus v minus v. Take LCM. 1 plus v minus v plus v square. V and v cancels, correct? So what do you have? x into dv by dx is equal to 1 plus v square by 1 minus v, correct? Now you know this is converted into variable separable form. Take all the v's on one side, take all the x on one more side, and then we just integrate it. Fine. Let's take the v on the other side now. See, we have 1 minus v by 1 plus v square. dv is equal to 1 by x dx. Now the next step is what? Integrate this one, correct? See, when we integrate, we split it. That means we'll do 1 by 1 plus v square minus v by 1 plus v square is equal to log of x plus log of c, right? Now the LHS part, it's very simple now. So this is going to be just tan inverse v minus 1 by 2 into log of 1 plus v square, yeah, is equal to log of x into c. Fair enough. So you can take the half log on the other side and you can simplify this one. So if you do that, you'll get tan inverse of v is equal to log of x into c plus log of log of 1 plus v square into half or divided by 2. Correct? Now, what is v? V is equal to y by x. Substitute. Okay, you can directly substitute, or you can just simplify it a little more further, which, you know, it's easier if you simplify this one. All right? You have tan inverse of y by x log of x into c plus half log 1 plus y square by x square. So this is going to be the answer, or any other forms of this particular answer is going to be the final. Clear? Now let's do the third problem. See the third problem. X square minus y square dx is equal to minus 2xy dy, correct? Right? dy by dx is equal to x square minus y square by 2xy, but with a negative sign. To solve this one, y is equal to v into x, correct? So y dash is equal to v plus x into v dash. Substitute. So you will get y dash is nothing but v plus x v dash. V plus x into v dash is equal to, now, x square minus v square x square divided by minus 2 times of, correct? So this is what we have. Numerator, can you see anything common? X square, right? By 1 minus v square by x square into minus 2v. See, we get v plus x into v dash 1 minus v square, or you know what we can do? We can write v square minus 1 by 2v. I think this makes a lot of more sense, right? Variable separable method now. Now, what do we have? X into dv by dx is equal to, so here you have v square minus 1 by 2v minus v, right? So take it to the other side, basically LCM, x into dv by dx, v square minus 2v square is minus v square, correct? 2v divided by minus of v square plus 1 is equal to 1 by x dx. Sorry, here we have dv. So this is what we have. Now on the LHS, take the denominator as t. In the sense, take v square plus 1 as t. 2v dv is equal to dt. And that's exactly what we have, right? So on the LHS part, you can write minus integral of dt divided by, so in this case, v square plus 1 is t, right? This is equal to log of x, of course, plus log of c. Here we have minus log of t, log of x into c, or you can also write minus t, right? So see, you can write minus t, or you can say 1 by t. 1 by t is equal to x into c. But what is t? T is v square plus 1. 1 by v square plus 1 is equal to x into c. Now, what is v? Y by x. Correct? That's a final substitution. So, when you take v by x, you can write 1 by v square or 1 divided by y square by x square, right? So, if you take LCM and if you solve it, you'll get x square by y square plus x square is equal to x into c. So, this is the answer for the third question. Now, let's do the fourth question. See the fourth problem. See here, what we are going to do, the dy by dx is that divide everything by x square. So dy by dx is equal to x square minus 2y square plus xy divided by x square, correct? Now, you know the substitution. We are going to take x is lambda x, y is equal to lambda y, right? So if you substitute that, y dash is equal to, you can take lambda square common everywhere. X square minus 2y square plus xy by lambda square into x square. So this is nothing but lambda power 0 f of x comma y. So it is a homogeneous differential equation. So now let's do the solving part. For the solving part, all of you know what we have to do, correct? So what we need to do, y is equal to v into x. Substitute. Here you have v plus x into v dash is equal to, guys, before you go further, like substituting y as v by x, sorry, y as v into x, divide individually. That means 1 minus 2 into y by x whole square plus x into y divided by x square, or this x and x cancels, right? So what do we have? V plus x into v dash, 1 minus 2 v square plus v. The v and v cancels out, correct? So what do we have? X into v dash, 1 minus 2 v square, right? So now what you do, you take it to the LHS. That means dv by 1 minus 2v square dx divided by x. Now this is of the form 1 by x square, sorry, 1 by a square minus x square, correct? When it's 1 by a square minus x square, you are going to get 1 by 2a log of a minus x by a plus x, right? So in this case, it is going to be half, first part, into 1 by 2a. So 1 by 2 into 2 log of 1 minus, so this is going to be a square minus x square, correct? So root 2 v by 1 plus root 2v, correct? This is equal to log of x plus log of c, isn't it? Now in this case, this is going to become 1 by 4 into log of, what is v? V is y by x. Substitute. So if you substitute, guys, you also have to take LCM, correct? This is going to become x minus root 2y by x plus root 2y is equal to log of x into c. So you can keep saying that this is going to be the final answer. Make sense? So this is the answer for the fourth question. Now let's do the fifth one. Fifth one, dy by dx. So this is going to become x into cos y by x, y into sine y by x, this into y by. So the next one is what? X into y sine y by x minus x cos y by x, correct? Now, you know that lambda x, lambda y if you take. Now, what I want you to see is there is one x here, y, y, correct? Along with that, x, y, x. Now, if you take these things together, then the lambda gets cancelled. So, we can clearly say it is homogeneous. Now, let's come to the solving part of it. Equal to v into x. So, here v plus x into v dash, x into cos v plus vx into sine v into vx, correct? Divided by x into vx sine v minus x cos v. The first x and x cancels. Again, take x as LCM. Sorry, not LCM. Take x as common. So you will have v plus x into v dash, the first part, x into cos v minus v sine v divided by x into v sine v minus cos v. X and x cancels, right? See, now what we minus, correct? So there is a plus here. Now what do? Take the v on the other side. That means this is going to become the same thing, whatever RHS you have, minus v, correct? Cos v plus v sine v by v sine v minus cos of v. But remember, there is an into v here, correct? Minus v. See, guys, why are you thinking there is a minus v? Is because of this v. This one. Cross multiply. As in, sorry, LCM. You take LCM. V cos v plus v square sine v minus v square sine v plus v cos v by v sine v minus cos v. This and this cancels out. So we have x into v dash 2v into cos v divided by v sine v minus cos v. Now we do the variable separable method. So we take the v that side, take the x this side, we do the math. All right. dv, or directly we can start by take dv, no problem. V sine v minus cos v divided by 2v cos v, correct, is equal to dx divided by x. LHS we need to simplify a little more further. So you are going to have dv, or first you can divide, individually divide. V and v cancels out. So you are going to have 1 by 2 tan v minus cos and cos cancels out. So you are going to have v, or 1 divided by 2v, correct? This one is equal to dx divided by x. Now we need to integrate this. So half tan of v is what? Log of cos x, correct? But you have a negative sign to that. So you can call it as log of secant x. Half log of secant x, correct, minus half log v log of x plus log of c. Right, so this can become, you can call it as root of secant x. So here you will going to have log of root of secant x minus log of, what is b, y by x, root of y by x log of x into c. So you can divide here. So if you divide, then you're going to have log of root of secant x by this one, which is root of x into secant x by y log of x into c, which is root of x secant x by y is equal to x into c. You can further simplify this if you want, which is root of secant x is equal to root of xy into c. This you can call it as the final one. All right, now let's do the last one. Trust me, just check. Again, we can do dy by dx, or we can do dx by dy also. That's also a possibility. So remember, we are taking y is equal to v into x. Now you can take x is equal to v into y. Okay, it's one and the same, guys. It makes no difference, actually speaking. All right. So what we'll do now, we'll take the dy by dx only because you guys are used to it. Fine. So you have 1 plus e to the power x by y into dx, right? So dx is equal to minus, or what you can do now is instead of 1 minus x by y, you can write x by y minus 1. So x by y minus 1 into e to the power of x by y dy. So dy by dx is equal to 1 plus e power x by y by e power x by y into x by y minus 1, right? Now, if you look at this one, e to the power x by y, obviously we cannot take that because it's a variable inside the function. So what is the value here? We can directly say lambda power 0 into f of x comma y, correct? Because there are no independent variables to substitute that x and y. So you might as well say that this is lambda power 0. Now what do we do? Let's do the next one. That is the solving part. All right. V into x, correct? So y dash, or in this case y dash, if you take v plus x into v dash, 1 plus e power by v, correct? By e power 1 by v into 1 by v minus 1. See, we have to do all these things. Fine. Now, you can multiply and then you can do it. That is v plus x into v dash 1 plus e power 1 by v by e power 1 by v divided by v minus e power 1 by v. So we'll erase this one. This is not really necessary. Take the v that side. X into dv by dx 1 plus e power 1 by v by e to the power of 1 by v minus this minus v. Guys, technically we just multiply, taking the LCM. So x into dv by dx 1 plus this minus, take this one, e to the power 1 by v plus v into e power 1 by v by this one. Cancels out, correct? So x into dv by dx 1 plus v into e power 1 by v by e power 1 by v into 1 by v minus 1. Now, variable separable method we have already reached. We'll take the v on one side, we'll take the x on one more side, and then integrate, directly integrate. Fine? 1 by v into, see, you can also write this as 1 minus v by v, correct? Right? Divided by 1 plus v into e power 1 by v dx divided by x. Okay? Now, we can multiply this and we can do it, or denominator, we can take it as t. See, if you take the denominator as t, this is equal to t. Then you will have e power 1 by v, this one, plus, see, remember, we are differentiating, correct? So, one derivative is anyway 0. V derivative is 1. So, e power 1 by v plus v e power 1 by v. This is equal to dt, correct? Now, you can take e to the power 1 by v common. So, if you to do that, e power 1 by v into 1 plus v dv is equal to dt, correct? See, now what we can do now is that we can substitute e to the power of 1 by v in terms of this dt and dv. So that, see, look at the numerator what we have. Numerator what we have is 1 minus v by v. Or you can also say 1 by v minus 1. And nowhere here we have 1 by v minus 1. So the direct substitution is not going to work, correct? So let's do the math. You have x by y, correct? Guys, I'll give you a hint and I want you guys to try it. See, I'll give you the answer also. The final answer is x plus y into e to the power of x by y is equal to c. See, this is the answer for the sixth one. Now that we have solved around 5 problems of the same type, the sixth one is also the same. Now, I want you to try it. Okay, so I want you to try it. If not, then you guys are going to have a video on this one and you guys can figure out how it is done. But be very honest and try it by yourself. And this is the answer what you need to get. Okay, so in the next video, we are going to learn about another topic in differential equation. That is the linear differential equation. We'll discuss that in the next video.